Now I am taking an example where we will decide whether the given progression is AP or not. If I write to check two things, one is 2, then 7, then 20, then 90 and dot dot dot. Another I am writing 7, 17, 27, 37. I want to see out of these two which is AP and which is not, or both AP or both are not AP. To check the first one, I need to calculate the differences of the successive terms. 7 minus 2, it is 5. Then 20 minus 7 is 13. 90 minus 20, it is 70. So what is this conclusion is drawn? It is that common differences are 5, 13 and 70. These are not equal, so this is only a progression. This is only a sequence. It may be formulated with some other specification, but the property of AP for maintaining the equal common difference is not maintained here. So first one is not an AP. This is not AP. For the checking of the second, to check the second one, 7, 17, 27, 37, difference of these two is coming 17 minus 7, 10, 27 minus 17 is 10, 37 minus 27 is 10. As the terms in the second are equally spaced having equal common difference, it means that this is an AP. So we say this is not an AP, whereas this is an AP. One more thing I want to explain you, that if someone has written an arithmetic progression, it may be like 5 plus 2 7, then 9, then 11, then 13, so on. In case you want to find the general term, nth term, it is given by a plus n minus 1 into d. An become 5 plus n minus 1 into d means common difference is 2 as the terms are equally spaced at the difference of 2. So an become 5 plus 2n minus 2, or answer comes out 2n plus 3. What is the use and what we should conclude? Use is, if I put n is equals to 1, I will get 2 into 1 is 2 plus 3, 5. First term. So a1 will be what? A1 will be 5. If I put n is equals to 2 both sides, so a2 will be 2 2 ja 4 plus 3 7, which is true. If I put 3, I will get 2 3 ja 6 plus 3 9. If I put 4, I will get 4 2 ja 8 plus 3 11, and so on. Suppose directly I want to find 100th term, a100, that will be 100 into 2, 200 plus 3, that is 203. So what? It means that if general term is given, we can find any term of that arithmetic progression, and always remember that the general term of AP is always linear in n, and the very important, whatever is the coefficient of the n or the linear term is known as the common difference. The common difference d is always equal to the coefficient what is given or maintained or with n, that is the linear term. So what is required to explain you that general term of every AP is always linear in n, and whatever coefficient of n, this is known as the common difference of that AP whose it is general term, and with the help of an we can find any term which is required to calculate. Now one more example based on the general term. Which term of arithmetic progression 3, 8, 13 dot 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 is 248. This we want to decide that when we will write this arithmetic progression further, that on which position 248 will lie. What is here? A 3, common difference 5, and term whose position is required to calculate is 248. We know that an is given by a plus n minus 1 into d. That is 248 is equals to a means 3 plus n minus 1 into d means what? Here d is 5. So what we are getting, that 248 is equals to 3 plus 5n minus 5. This minus 5 plus 3 become minus 2. Transferred will give us 5n is equals to 250. Because minus 2 and 248 when added will transfer become positive and become 250. So the answer of n will be 50. So we can say that 248 will be 50th term of this arithmetic progression. So with the help of this formula of general term, we are able to calculate the position, we are able to calculate any term, and we are able to calculate either a or n or d, whatever is missing or required in the problem. Now I am taking an example where again we will make use of general term. Which term of sequence 24, 23 and 1 by 4, 22 and 1 by 4 dot 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 is first negative term. So it is like this. First term a is what? 24. Common difference d, that is 23 and 1 by 4 minus 24, that become minus 3 by 4. As this is the decreasing arithmetic progression, so there will be a situation that the terms will start coming negative. Our task in the problem is to diagnose, to check that which term will be the first negative term. Let us suppose an is the first negative term and formula for an is a plus n minus 1 into d. So the general term become 24 plus n minus 1 into d means minus 3 by 4. Taking the LCM 4, this become 96 minus 3n then plus 3. Minus 3 when multiplied to this become 99 minus 3n upon 4 is the general term of this given progression. We have to use to find the first negative term. That's why we say an is less than 0. Negative starts only if it is less than 0. But what is an? 99 minus 3n upon 4 less than 0. So this become 99 minus 3n less than 0, or we can say minus 3n is less than minus 99. But you know, in the matter of inequalities, when this negative transfers, this inequality always get reversed. So you will notice 3n is greater than 99, or you can say n is greater than 99 upon 3, that is n is greater than 33. It means what? If n is greater than 33 means what is the first value which is greater than 33 is 34. So we will say 34th term will be the first negative term, and after it all the next terms will be negative. Now one more important fact which we'll use to solve the problems of arithmetic progression, which is based on finding of the sum of n terms of any arithmetic progressions. Result is very well known to you. If first term is a, second is a plus d, third is a plus 2d, and last is a plus n minus 1 into d. Their sum if is represented by Sn, its formula is Sn is equals to n by 2 2a plus n minus 1 into d. This result is being developed by the Gauss and is also explained when we have told you about the AP in class 10th. So the proof we are not providing you as it is available in class 10th AP's videos. Question is that what are the more uses and applications of this result? To explain you, if I take first term is 2, then 6 is added, I am taking 6 as the common difference, then become 8, then become 14, then become 20. This is an arithmetic progression with first term 2 and common difference 6. A is 2 and common difference is 6. Only these two things. If I want to find Sn, answer is n by 2 into 2a, that is 2 into 2, plus n minus 1, I am finding the general, that is n is n, common difference is 6. So answer of Sn is coming n by 2, 4 plus 6n minus 6, or become n by 2, 6n minus 6 plus 4, this gives you minus 2, and this become, if 2 is common and cancelled by this 2, this become n into 3n minus 1, or most simplified form is 3n square minus n. So if 2, 8, 14, 20 is an arithmetic progression and I want to calculate its general Sn, so this become Sn is equals to n by 2, 2a plus n minus 1 into d, and its simplification is giving 3n square minus n. Now I want to tell you what are the uses of 3n square minus n. If Sn is 3n square minus n, so remember there is never any constant term in the Sn of any arithmetic progression. It is always quadratic, as n by 2 is multiplied with the whole. So there is no scope that there will be any constant term, number 1. So always remember, whenever a general Sn is given, there will be no constant term. And second thing to note, whatever is the coefficient of n square, double of that will be always common difference. Here n square's coefficient is 3. It means that 3 2 is 6. Common difference of that arithmetic progression will be what? 6. And that is equal to double of the coefficient of the squared term in Sn. And if I ask you to put n is equals to 1, you will find 2, that is sum of first term. If I ask you to put n is equals to 2, this will become 2 2 is 4, 3 is 12 minus 2, that is what? 10. And you will notice 8 plus 2, sum of two terms is 10. Similarly, you can put 3, you will get sum of 3 terms. You will put 4, you will get sum of first 4 terms. So these are the applications and informations about the sum of n terms of any arithmetic progression. Now I am explaining you very important, useful and different type of example based on the Sn. The sum of n terms of two APs are in the ratio of 3n plus 8 is to 7n plus 15. That is what? There were two APs. Sn of first AP is calculated, then Sn of second AP is calculated, and these two results are divided for its simplest form, which is known as the ratio, and comes out to be 3n plus 8 is to 7n plus 15. There were two APs, their Sn's ratio is this. Then find the ratio of their 12th term. Generally, students commit a that is not the ratio of 12th term. That is the ratio of sum of first 12 terms of two APs. For it, the shortcut is that we want to find the ratio of the 12th terms, not the sum of first 12 terms. Whatever is ratio required, which terms ratio is required, make its double. 12 into 2, subtract 1, this become 23. 12 2 are 24, minus 1 become 23. We will replace both n's by 23. We have Sn of first upon Sn of second is 3n plus 8 upon 7n plus 15, and we want to find what is A12 of first and A12 of second. I am mentioning by dash to differentiate. This we want to calculate. In order to calculate the ratio of 12th term, I told you which term is required to calculate the ratio. Make its double and subtract 1. Put that in place of n in essence to get ratios of these particular terms. So A12 upon A-12 of this particular result become 3 into 23 plus 8 upon 7 into 23 plus 15. If I solve, I will get this result is 7 by 16. So ratio of 12th terms of those two APs whose ratio of general sum of n terms is given by this is 7 by 16, or you can write 7:16. Now one more problem based on Sn. The ratio of sums of m and n terms of an AP. We have one AP. First we have obtained the sum of m terms, then we have obtained the sum of n terms. The ratio of these two terms is coming m square is to n square. That is Sm upon Sn is m square upon n square. We can write Sm as m by 2 into 2a plus n minus 1 into d. And Sn can be written as n by 2 2a plus n minus 1 into d, and that result is given equal to m square upon n square. So 2 and 2, m and square, n and this square get cancelled. We left with 2a plus m minus 1 into d upon 2a plus n minus 1 into d is equals to m upon n. If we make it cross multiplication, we will obtain 2an plus mnd minus nd is equals to 2am plus mnd minus md. By doing this, m and d positive both sides get cancelled, and if minus md is transferred, I will get m minus n into d is equals to 2a common m minus n. M minus n get cancelled, this become d is equal to 2a. If d is equals to 2a, meaning by what? That d and that common difference is double of this. What actually we want to extract, so that the ratio of mth and nth term, that is am upon an. Am is m, the formula for am will be a plus m minus 1 into d, and for an will be a plus n minus 1 into d. Here d will be replaced by 2a. If we will do so, and on calculating, we will get the result will be 2m minus 1 upon 2n minus 1. So the use of this d is equal to 2a when made here, the answer will come which is required to prove.